Hello everyone, this is Akansh Suman here. Now we are going to solve the questions based on the single slider crank mechanisms. In the steam engine, crank length has 50 centimeter. That is the length of the crank. We need to draw the diagram so it would be easy to understand what is given data. Okay. So this is basically connecting rod and this is crank and this is the line of stroke. You can see here. This is the line of stroke of the piston. So this is the complete diagram. Okay. Here you can see this is our piston. Okay, and this is connecting rod and this is the theta. This is theta. This is the center of crank rotation and this is our crank. In the question, the crank length is given, that is 50 centimeter. Okay, so I'm just writing here that is 50 centimeter, and the length of the connecting rod is given, that is 200 centimeter. When the crank is perpendicular to the connecting rod, see here, don't apply this angle as 90 degree unless and until it is mentioned. Okay, so if in the question it is mentioned that maximum area of the triangle, that means this angle is 90 degree. Otherwise, he will give you directly like that when the crank is perpendicular to the connecting rod. Okay. Otherwise, this angle not always 90 degree. Okay. He has to mention in the question if this angle is 90 degree. He has to mention in the question that whether the maximum area of the triangle or crank is perpendicular to the connecting rod. Okay. Otherwise, it will not be the 90 degree always. So when the crank is perpendicular to the connecting rod, so this is the 90 degree. So piston effort is also given. That means denoted as 100 kilonewton F. Okay, this is 100 kilonewton. We need to calculate the turning moment on the crankshaft in kilonewton into meter. Remember this unit. When you get the answer, when you solve the questions and you will get the answer, before putting the answer in the exam, you just have to check in which unit it is asking. Okay, in which unit the answer is asking, because it is very important. Sometimes if you make this mistake of unit, it would be considered as an error mistake. Okay, so this is just you can reduce this type of error just by doing practice a lot of questions. So in the question it is asking that turning moment of the crankshaft. First we need to know what is the formula for the turning moment of the crankshaft. That is noted as T, and we know that this is equal to the Ft. Tangential force on the crank into R. Sometimes it is called tangential force on the crank, or sometimes it is called as crank effort. So first we need to calculate Ft. This is our equation number 1. Now we are going to solve the tangential force Ft. We know that this is the force on the connecting rod is considered as Fc. Okay, force of connecting rod. So this is the basically Fc. We have seen in the derivations. This is Fc, and this angle is theta. So this would be theta. Okay, if this is beta with the horizontal, this would be beta because this is horizontal line. Okay, so complete, you can see this is complete angle is theta plus beta. So this would be the Fc cos theta plus beta, and another component that would be perpendicular to the crank. This would be like that, Fc sin theta plus beta. This is the tangential force on the crank shaft bearing. Okay, this is our crank shaft and this is the crankshaft bearing. So this is the tangential force that is denoted as Ft. Okay, so Ft is equal to Fc sin theta plus beta, but we don't know the value of Fc, so we can convert it into the piston effort. We know that F is equal to Fc cos beta, so Fc would be equal to F upon cos beta multiply sin theta plus beta. We don't know the value of theta and also beta. How can we calculate the value of theta and beta? See here, this is a complete triangle, you can see, and the length of the this connecting rod and the length of the crank is given. So we can calculate first the theta. So I'm just calculating here. Tan theta is equal to 200 upon 60. So from here you can get the value of theta. Okay, so when you solve this, we'll get the value of theta, and that would comes out to be 73.3 degree. 73.3 degree. Okay, similarly you can calculate the value of beta. Okay, since here this is 90-degree angle is given in the question, so if I consider this angle as beta, so also we can calculate 10 beta, that is equal to 50. This is not 60, actually this is 50. Okay, so sorry for mistake, this is 50. So you will get the value of theta 75.96. It would comes out to be 75.96. 75.96 degree. Okay. Now similarly you can calculate the 10 beta, that means 50 upon 200, that means beta value comes out to be 14.03. 14.03, or you can subtract 75.96 from 90 degree, you will get 14.03. This is another way. Okay, so you can apply these values in these equations. We know that the crank effort is F is 100 kilonewton. I am not converting kilonewton into newton because in the question it is asking in kilonewton into meter. So I'm not converting this kilonewton into newton. Okay, so just as it is, I'm writing here 100 kilonewton upon cos beta. Beta means 14.03. So that means 14.03 cos, and this is sine. Theta plus beta is what? If you see here 75.96 plus 14.03, what would be the value you will get? Tell me. This would be 90 degree. Okay, because this is complete angle, this is actual to 90 degree. So sine 90 is equal to 1. We know that sine 90 is equal to 1. So you will get the value of Ft. From here we can get the value of tangential force on the crank bearing or crank effort. That would be 100 upon cos 14.03. 100 upon cos 14.03. So when you solve these equations, you will get the value of tangential force or crank effort, and that would comes out to be 103.07 kilonewton. Okay, now we just have to use equation number 1. If this is equation number, we can calculate the turning moment. So that would be Ft into R, that means 103.07 multiplication of R, that means R is nothing but the radius of the crank, that is 50 in centimeter. You must have to convert into meter by dividing by 100, and you will get the value of turning moment. That would comes out to be 51.53 is the answer. 51.53 kilonewton into meter. Okay.